let us see the derivation of normal or perpendicular form of a straight line. Here the equation we have to derive x cos alpha plus y sin alpha is equal to p. Here alpha is the angle between the perpendicular on line by origin and the x-axis, and the p is the length of the perpendicular drawn from origin to the line. So let us first draw a line. You see, this is our line. Okay, so we have a line. This first I explain here the graph. This is our x-axis, this is our y-axis, and this one is our line. We have to find the equation of this red line. So they have given a perpendicular. They have given a perpendicular from origin to the line. Okay, this is the perpendicular they have given us. This is 90 degree. Okay, now this is 90 degree. This is the normal to the line from origin, and there is a point P on this line whose coordinates are x, y, and the length of this perpendicular, we know that this is the OM is perpendicular, and the length of this perpendicular is P, denoted by P, small p. The capital P is the point. What we have to do, we will draw a perpendicular from point P on x-axis. Just a moment. This is the perpendicular from x-axis, perpendicular from P on x-axis. Now we draw another perpendicular from this point. This is point V, assume it is N. This point is N. This is also perpendicular. Okay, now we draw another perpendicular to OM from point N. So we draw another perpendicular from this point on here. This is our perpendicular now, and another perpendicular we are drawing from point P to point P2. This is point L. I give some name to this point also. This is point L. So we draw another perpendicular on NL from point P. So we draw this perpendicular here. It is a perpendicular normal form, so there are so many perpendiculars there. We have to draw. Just a moment. I give some name here also. So I give name Q. It is PQ. It is also perpendicular. This one is also perpendicular. We have draw one perpendicular is this, one perpendicular is this, one perpendicular is this, and one perpendicular. 1, 2, 3, 4 perpendicular we have drawn there. So now you see the angle, this angle they have given us, this angle they have given us alpha, angle between the perpendicular on line and the length of perpendicular is given to us. Now let us see in triangle OLN, P is the length only, so here L is the point, so OLN in triangle OLN, angle L is equal to 90 degree, angle O is equal to alpha. So if we see, we have to find out OL. Find out OL. OL, and we know ON. ON is X here because the coordinates of point P is X and Y, so ON is X and PN is Y. OL is here base because the 90 degree and the angle both are on the same side, so it is the base, and this one is the hypotenuse because opposite to the right angle. So base upon hypotenuse is equal to cos, and with respect to alpha it is cos alpha. So OL upon ON is X is equal to cos alpha. Therefore OL is equal to X cos alpha. This we have got here. Okay. Now in triangle PQN, angle Q is 90 degree. We know that this one is 90 degree here, and this one is alpha. Why it is alpha? Because it is 90 degree. So this is a triangle, this one is, and this is alpha, this one is 90 degree, so this is 90 minus alpha. This total angle is 90 degree, so this 90 minus alpha, therefore it is alpha. So angle N is equal to alpha. Now we have to find out PQ. PQ, which is perpendicular opposite to alpha, by PN. PQ is perpendicular, PN is hypotenuse, so it is sin alpha. Therefore PQ, PN is Y, is equal to sin alpha. Therefore PQ is equal to Y sin alpha. So we have got these two things, PQ is equal to Y sin alpha, and PQ is equal to LM. PQ and LM both are equal because these two parallel lines are here, so it is equal to LM also. Now OM, this OM is equal to OL plus Lm. OL plus Lm. OL is this one, this OL, this one is Lm, so this is OM, total is OM. So you see here OM is equal to P, which is P, the length of OM is P, is equal to, just a moment, I change the brush. OM is P, P is equal to OL, we know that x cos alpha, here OL is x cos alpha, plus Lm is y sin alpha. So in this way we could easily derive the equation of normal form of a straight line